Good day everyone, my name is Naya Moneva and for today's video I will be going to discuss about process management in the operating system. Process management is one of the core functions of an operating system. It deals with creating, running, and terminating processes, ensuring each programs get the CPU time and resource it needs. So next, we have responsibilities of process management. First, we have process creation. Process creation means that the operating system creates a new process whenever you open an application. For example, when you open Chrome or a game, the OS creates a process for it to run. Each process receives a process ID or PID, memory space, CPU time, and other resources needed to work properly. In short, process creation is the OS preparing everything so the program can run smoothly. Second, we have process scheduling. Process scheduling is the OS choosing which process get to use the CPU next. Since many apps and background tasks run at the same time, the OS must decide who runs first, who waits, and how long each process can use the CPU. To this, the OS uses scheduling algorithm like first come first serve, shortest job first, round robin, and priority scheduling. In simple words, process scheduling makes sure all processes get a fair chance to run without slowing down the system. Third, we have process state. Process state describes the different stages a process goes through. New, the process is just created. Ready, waiting for the CPU time. Running, currently being executed. Waiting, black, waiting for something like input or data. Terminated, finish or close. In short, these states help the OS track what each process is doing. Fourth, we have a process control block, PCB. The PCB is like the information card of a process. It stores information details such as process ID, program counter, CPU registers, memory limits, process state, priority level. If we have context switching, context switching happens when the CPU stops working on one process and moves to another. The OS saves the current process state and then loads the next process state. This allows multiple programs to run smoothly even if they take turns using the CPU. Next, we have Inter-Process Communication, IPC. Inter-Process Communication or IPC is how processes communication or share information with each other. They can send data through methods like pipes, message queues, shared memory, sockets. In simple terms, IPC lets processes talk and work together. 7. Process synchronization prevents problem when multiple processes try to use the same resource at the same time. It makes sure they don't conflict or interrupt each other. The OS uses tools like semaphores and mutex to control access and keep everything safe and organized. 8. Process termination. Process termination is when a process ends. This can happen because it finished a task. The user closed it, the OS stopped it, or it encountered an error. When a process terminates, the OS frees its memory and resource. So now let's proceed on the last part, which is the importance of process management. Process management is important because it helps the operating system run smoothly and efficiently. First, efficient CPU usage. Make sure the CPU is used properly without wasting time. Second, smooth multitasking. Let multiple programs run at the same time without crashing. Third, stability and security. Keeps the system stable and prevent errors or conflicts. Fourth, fair resource sharing. Ensures all processes get the resource they need. And last, fast system performance. Improves overall speed and responsiveness of the computer.